In the cold, endless ocean of space, the James Webb Space Telescope has just spotted something so extraordinary that it could completely rewrite what we thought we knew about life in the cosmos. Orbiting a small red star only 4.2 light-years away is Proxima Centauri B, a rocky exoplanet that, until now, was just another candidate in the long list of, maybe habitable, worlds. But the Webb's latest observations have revealed clues that defy expectations, hints of conditions where life might not only exist but could be thriving in one of the most unlikely places imaginable. Proxima B is no Earth twin. It's about 30% larger than our planet, locked in a tight orbit just 27 million kilometers from its dim, temperamental star, Proxima Centauri. That close proximity means it's blasted by frequent, violent solar flares capable of stripping atmospheres bare and bathing its surface in deadly radiation. To make things even stranger, the planet is tidally locked. One side is in permanent daylight, scorched and hostile, while the other lies in eternal night, frozen under an unending shadow. And yet, there's a narrow strip between the two extremes, a twilight band known as the *terminator zone. Here, temperatures could remain steady enough for liquid water to exist, the first ingredient in the recipe for life as we know it. In this perpetual dusk, the harsh glare of day never comes, nor does the killing cold of night. It's in this fragile ribbon of habitability that Webb's instruments have detected something breathtaking: chemical fingerprints in the atmosphere, oxygen, methane, and carbon dioxide, in unusual proportions. This mix of gases, especially oxygen and methane together, is intriguing because on Earth such a combination rarely occurs without biological activity. Scientists caution: this is not proof of life. Geological or chemical processes could, in theory, produce similar signals. But the ratios and patterns of these gases lean toward something stranger, processes that might be biological in nature. If life exists there, it would have to endure extremes unlike anything found on Earth. It might take shelter underground, shielded from deadly radiation, or develop molecular defenses we can barely imagine. Some life forms could even harness the dim, reddish glow of the terminator zone as an energy source, evolving in ways that challenge our very definition of habitability. The James Webb Telescope made this discovery by watching starlight filter through Proxima B's atmosphere during a planetary transit. Its 6.5-meter mirror and ultra-sensitive infrared instruments broke that light into a spectrum, revealing the telltale absorption lines of specific molecules. This precision is why Webb has become humanity's most powerful tool for sniffing out possible life signs beyond our solar system. Proxima B's closeness gives it a unique place in our search. While other fascinating worlds like TRAPPIST-1e or LHS 1140b sit many light-years farther away, this planet is right next door. Within reach of future probe missions like Breakthrough Starshot**, which aims to send swarms of laser-propelled nanocraft racing toward Proxima B, arriving in just a few decades. The implications are staggering. If even microbial life exists there, it would mean life is not a rare cosmic accident, it's a natural outcome wherever the right conditions appear. Humanity would no longer be asking, "Are we alone?" but, "How many neighbors do we have?" Still, the road to confirmation is long. Methane can come from volcanoes, oxygen from water molecules split apart by radiation. Scientists will need to observe over multiple transits, searching for repeating patterns that can't be explained by geology or chemistry alone. Yet, even at this early stage, Proxima B has given us something profound. A reason to believe that life might be closer than we dared to dream, thriving in a band of eternal twilight, just across the cosmic street from Earth. And if the lights of a distant city were someday to flicker in that dim glow, we might finally know that the universe has been To push the investigation further, scientists know they'll need tools even more powerful than the James Webb Telescope. Instruments like the Extremely Large Telescope, ELT, and the planned Habitable Exoplanet Observatory, HABEX, are designed to do what Webb can't: directly capture images of Proxima B's surface and atmosphere with unprecedented clarity. These future observatories could show us not just spectral lines and chemical traces, but potentially visible signs of landscapes, cloud systems, and, if they exist, artificial lights. The news of Webb's findings has rippled across the globe, sparking excitement in scientists, philosophers, and everyday dreamers alike. For some, it feels like the dawn of a new era in astronomy, a turning point where the question of life beyond Earth shifts from if to how soon will we find it. Others urge restraint, pointing out that extraordinary claims demand extraordinary evidence, and the current data is far from final. Still, one consensus is clear: Proxima B demands our full attention. There's another possibility, one that's thrilling and unsettling in equal measure. What if the signals we're detecting aren't natural at all, but the work of an intelligent civilization? Imagine an advanced society that has learned to flourish in Proxima B's twilight band, harnessing the energy of its star to power sprawling cities, orbital stations, or vast planetary-scale energy grids. Lights glowing in the eternal dusk could be more than geological curiosities. They might be engineered beacons, visible across light years. But that possibility comes with profound questions. How advanced would they be? If they detected us in return, would they welcome contact, or avoid it? Could we even communicate responsibly across such a gulf of experience and technology? And perhaps most importantly, are we ready, as a species, for the reality of meeting another civilization? The search for life is not only about science, it's about ethics, caution, and the humility to admit how little we truly know. In the months ahead, Webb will continue scanning Proxima B, hunting for repeating chemical patterns, seasonal changes, and any spectral hints that could strengthen the case for life. On Earth, construction on the ELT and other next-generation observatories will move forward, while private and international efforts like Breakthrough Starshot prepare for missions that could, within decades, send tiny laser-propelled probes hurtling toward Proxima Centauri at a fraction of light speed. If these future missions succeed, we could receive the first direct photographs of another planet's surface, not blurry specks of light, but detailed images of continents, oceans, ice caps, or perhaps something even more astonishing. What makes the Proxima B discovery so groundbreaking is that it expands our concept of habitability itself. Life here on Earth evolved under gentle conditions compared to Proxima B's extremes. Yet if life exists there, it means survival and adaptation can take forms we haven't even begun to imagine. This understanding could reshape not just where we look for life, but how we prepare to live on other worlds ourselves. Whatever the outcome, the signals from Proxima B mark a new chapter in humanity's search for cosmic company. They challenge us to look beyond the familiar, to prepare for discoveries that could redefine our place in the universe. Whether the origin is volcanic, chemical, or intelligent, Proxima B has already given us something priceless. A reminder that the unknown is still out there, waiting for us to find it. We are living in an age where questions that once belonged to science fiction are now matters of real scientific inquiry. With every new observation, we take another step toward understanding not only if we are alone, but what kinds of neighbors the universe might hold. The cosmos is speaking. Proxima B may be only the first whisper in a conversation that will change humanity forever.